The inverting amplifier is to be capacitor coupled and to have a signal frequency range of 10 Hz to 1 kHz. If the load resistance is 250 ohm, calculate the required capacitor values. The voltage gain is to be 50 and the voltage output voltage amplitude is 2.5 volt. So if you see the last line, it is same as the previous problem, right? The voltage gain is given as 50 and your output voltage is given as 2.5 volt. So I am going to design it once again. So the modification what we are going to give in the circuit is it is a capacitor coupled inverting amplifier. So VCC minus VEE. Let me first draw the diagram. So non-inverting terminal will be grounded. Across the inverting terminal, you are going to apply the input voltage VI. Since it is capacitor coupled, you have the capacitor in the input and the output side. And since the frequency range is given, you are going to include the feedback capacitor right across the feedback row. So you will be having a resistor. In the output, you will be again having your capacitor. Okay, V0. So you are going to include your capacitor in the feedback also. So CF, let me take this as R1, R2, C1 and C2. Okay, now design, you have to find out the value for. So if I give a resistor R3 here, R1, R2, R3 and CF, C1, C2 are the parameters which you have to find out. Okay, so first let me continue with the previous, as per the previous problem. So you know that I2 will be equal to 100 times of IB max input bias current, maximum input bias current. So since it is a 741 op amp, I2 will be equal to 100 into 500 nano ampere. So I2 will be equal to 50 microampere, right? So if I2 is equal to 50 microampere, what will be your value for R2? R2 is equal to V0 divided by I1. So what is your V0? V0 is given as 2.5 volts. So R2 is equal to, I1 is nothing but equal to I2. So V0 is equal to 2.5 volt. What is your I2? I2 is equal to 50 microampere. So R2 will be equal to 50 kilo ohm. So you are going to take R2 is equal to 47 kilo ohm standard value. Okay, R2 you have got. Now what will be your R1? So R1 will be equal to VI divided by I2. So what will be your VI? How can you find out VI? V0 is equal to, or ACL, closed loop gain, is equal to V0 divided by VI. So from this, VI is equal to V0 divided by ACL. So what is your V0? 2.5 volt. What is your ACL, which is given as 50? So VI will be equal to 50 millivolt, right? So you can find out what is R1. R1 is equal to 50 millivolt. That is VI divided by I2 is again 50 microampere. So R1 will be equal to 1 kilo ohm. Okay. Now what will be your R3? R3 will be equal to R1 parallel to R2. So 1 kilo ohm parallel to 47 kilo ohm. So it is parallel combination. So R3 will be approximately equal to 1 kilo ohm. So these are the values which we have found out. So let me write down the value. R1 is equal to 1 kilo ohm. R3 is equal to 1 kilo ohm, right? And R2 is equal to 47 kilo ohm. Now you have to find out the value for C1, C2 and CF. So you know that as per the design of a capacitor coupled inverting amplifier, what is your XC1? XC1 is equal to R1 divided by 10 at F1. What is your XC2? XC2 is equal to RL. So here you can the resistor RL also, RL at F1. And what is your XCF? XCF is equal to R2 at the upper cutoff frequency, that is F2. So F1 is also given, F2 is also given in your problem. So can we find it? So what is your XC1? XC1, you know that, which is equal to 1 by 2 pi FC1. when you substitute in this formula, what will be your, you have to find out C1. So I can write that C1 is equal to 1 by 2 pi F1 into R1 divided by 10, right? We are going to apply this formula. So C1 is equal to 1 by 2 pi into, what is F1? F1 is equal to 10 Hertz, right? 10 Hertz into R1 is equal to, you have calculated the value for R1. It is equal to 1 kilo ohm. 1 kilo ohm divided by 10. So you will be getting C1 is equal to 159 microfarad. Okay. So you can approximate, you can use C1 180 microfarad standard value. Okay, so C1 is equal to 180. So let me write here 180 microfarad. Now what will be your C2? If I write C2 is equal to, if I apply in this formula, C2 is equal to 1 by 2 pi F1 into RL. So which will be equal to 1 by 2 pi, again it is equal to 10 Hertz. 10 Hertz into RL is given in your problem, so 250 ohm. So C2, after solving, you will be getting it as 64 microfarad. You will be using 75 microfarad standard value. So C2 is equal to 75 microfarad, which is equal to 75 microfarad. The last value which you have to find out is CF. CF is equal to 1 by 2 pi F2, right? Upper cutoff frequency into your R2. So which is equal to 1 by 2 pi. What is your F2 given in your problem? 1 kilohertz, right? 1K into R2, what you have found out? 47 kilo. So CF will be equal to, you will be getting 3386 picofarad, where you can approximate it to, you can use 3300 picofarad standard value. So you will be getting CF is equal to 3300 picofarad. Okay. So this is your final design of your capacitor coupled inverting amplifier.